लगवाता हूँ मैं।
वो
फिर
पढ़ते
मैंने
सर,
उसको
वो पढ़ ना भी पढ़े फिर भी ग्रेड निकाल लेते। पता नहीं पिछली बार क्या हुआ।
बेटा जी ऐसा नहीं है, पिछली दफा नहीं पढ़ा था तो नहीं निकले थे ना ग्रेड्स।
नहीं सर, पढ़ा था मगर पता नहीं लग।
ओके, अब हम लोग आते हैं, जरा क्वेश्चन डिस्कस करते हैं। हो सकता है आपको इसमें कुछ चीजें नई आपके लिए हेल्पफुल हों। ठीक है, ओके रेडी।
जी।
ओके, लेट्स से आपको कह रहा है कि अ टॉर्च हैज अ सिंपल सर्किट विद 3 वोल्ट बैटरी एंड अ लैंप, देयर इज अ 20 मिली एम्पियर करंट इन द लैंप, सो हाउ मच एनर्जी ट्रांसफर्ड टू द लैंप इन 5 मिनट्स। सो वेरी सिंपल क्वेश्चन, लेकिन हमें कुछ इंपॉर्टेंट चीजें रिक्वायर्ड हैं यहाँ पे, एंड व्हाट आर दोज। सबसे पहले आपने हाईलाइट करना है कि गिवन क्या क्या है, क्या क्या गिवन है जी आपके पास। V गिवन है, ठीक है, जस्ट राइट इट V। उसके बाद आपके पास करंट गिवन है, I गिवन है। आफ्टर दैट यू हैव टाइम, और कैलकुलेट क्या करना है, कैलकुलेट हमने करना है एनर्जी। ऐसे ही है ना।
जी।
अब आपके जहन में कोई ऐसा फॉर्मूला आ रहा है जिससे हम लोग ये कर सकेंगे, वोल्टेज करंट एंड टाइम को एनर्जी में कन्वर्ट कर सकें। नहीं ना, क्योंकि फॉर्मूले नहीं याद किए आपने। आप याद करो, आपको हमने एक फॉर्मूला लिखवाया था, एनर्जी इज
एनर्जी इज
इक्वल
इक्वल
टू
टू
वी
वोल्ट
आई
आई टी।
टी। ठीक है, वी आई टी, ये फॉर्मूला
जी।
आपको याद होगा तो तब आप काम कर पाएंगे। ओके, सो एनर्जी का फॉर्मूला क्या हो गया, वी आई टी, व्हेन वी आई एंड टी आर गिवन, तो जस्ट मल्टीप्लाई कर दो, दैट्स इट। सिर्फ कन्वर्शन करनी है, वोल्टेज आर 3, करंट इज 20, सो 20 बाय 1000 कर दो क्योंकि 20 मिली है। ओके, एंड टाइम इज 5 मिनट्स, सो इसको सेकंड में कन्वर्ट कर दो, तो इट इज 300 सेकंड्स। सो जस्ट सिंप्लीफाई करिए तो क्या आ जाएगा,
18।
यस, ठीक है, तो 18 जॉल आपके पास आ जाएगा। सो सिंपल, आगे चलते हैं, ये समझ आ गया।
जी।
ओके, अब ये वाला क्वेश्चन आपने ट्राई करना है, जल्दी से बताइए। एवरेज करंट गिवन है, ठीक है, उसके बाद आपके पास एनर्जी गिवन है, उसके बाद आपके पास टाइम गिवन है, तो निकालना क्या है हमने,
इलेक्ट्रोमोटिव फोर्स।
वोल्टेजेस निकालना है। ठीक है, तो अगेन क्या करेंगे हम लोग, हाँ बताइए शाबाश।
डब्ल्यू डिवाइड बाई क्यू, वर्क
खुदा,
डिवाइड बाई चार्ज।
अल्लाह ताला तुम्हें हदायत दे। अभी ऊपर क्या किया हमने,
वी आई टी।
हाँ पुत्र, मैं थोड़ी देर जो है ना वो सब्र करता हूँ, फिर मैं डांटना शुरू कर दूंगा। अभी ऊपर हम लोगों ने सेम यही काम किया, उसी का क्वेश्चन नंबर 2 मैंने आपको दिया, और मैंने लिखा भी है कि टी इधर है, वी आई इधर है, ई इधर है, वी निकालना है। तो आपके दिमाग में कैसे डायरेक्ट ई इज इक्वल टू क्यू बाई वी आ गया।
अच्छा, मैंने ईएमएफ ही नहीं देखा था।
गौर से आंखें खोल के देखना है, अल्लाह ताला ने ये जो दो लाइटें लगाई होती है ना, इनका फायदा उठाना होता है। तो आपने वी निकालना है, तो वी को सब्जेक्ट बनाओ, तो वी इज इक्वल टू ई डिवाइडेड बाई आई टाइम्स टी हो जाएगा। ठीक है, अब वैल्यूज पुट करो, 3.0 इंटू 10 की पावर 8, इट इज टोटल एनर्जी। और आपके पास करंट कितना है, करंट इज 1.5 इंटू 10 की पावर 4, और व्हाट इज द टाइम, 2.0 इंटू 10 की पावर -4। तो जरा कैलकुलेटर पकड़ो, 10 पावर +4 -4 कैंसिल, तो इट वुड बी 3.0 इंटू 10 की पावर 8 डिवाइडेड बाय 1.5 इंटू 2 कितना हो जाएगा, 3 हो जाएगा। तो ये 3 इंटू 1, 1 इंटू 10 की पावर 8 हो जाएगा, 1.0 इंटू 10 की पावर 8 हो गया। सही है,
जी।
ऑप्शन सी। तो अब ये चीज मेरा नहीं है कि तुम भूल जाओगे, सर एनर्जी, वोल्टेज और करंट का क्या रिलेशन होता है। ठीक है, अब आइए जी इस पे, क्वेश्चन नंबर 3 पे आइए। विच क्वांटिटी इज मेजर्ड इन कूलम्स, तो हम कौन सी क्वांटिटी को कूलम में मेजर करते हैं।
करंट, एम्पेयर।
देखो ये क्लास रिकॉर्ड हो रही है, मैं ज्यादा इसलिए सब्र और इस्तकामत से काम ले रहा हूँ। अपने होशो आवाज को ठिकाने में रख के मुझे आंसर करना है।
करंट,
करंट का यूनिट क्या होता है।
एम्पेयर।
ओके, तो हमने किसका मांगा है।
चार्ज।
यस, ठीक है, तो आपके पास कूलम जो है वो चार्ज का यूनिट है। शाबाश। IG3 का बच्चा पेपर देने जा रहा है और मैं अगर उससे ये पूछूं और वो गलत बताए तो फिर तो उसको ढूंढ ढूंढ के फैंटी लगाने की जरूरत है। इस पे आइए। अ सर्किट शॉन इन इन शॉन इंक्लूड्स 2 meters x and y कनेक्टेड है। ठीक है, तो बोला है विच रो गिव्स द unit and quantity measured by x and which row gives the unit and quantity measured by y। ये मैं दोनों, ये इतना कर दिया मैंने, अब आपको दोनों दिख रहे होंगे। तो क्या आपका x क्या मेजर करेगा और y क्या मेजर करेगा। आप सबसे पहले मुझे बताइए कि x और y कैसे लगे हुए हैं, आर दे इन सीरीज और पैरेलल।
पैरेलल।
पैरेलल। और कौन सा मीटर जो है वो पैरेलल में लगता है।
सर एक्स वोल्ट है और दूसरा वो एमीटर।
ओह माय गॉड, तो एमीटर पैरेलल में लगता है। एमीटर इज ऑलवेज कनेक्टेड इन सीरीज। ठीक है, ये बात याद रखना। सो बोथ ऑफ देम आर वोल्ट मीटर्स। तो ऑप्शन ए एंड बी आर गॉन, तो वोल्ट मीटर्स हैं। अब आप मुझे ये बताइए कि दोनों अगर वोल्ट मीटर हैं तो दोनों क्या रीड करेंगे।
वोल्टेज, वोल्ट।
वोल्टेज। गॉट इट। जी सर, आगे वाले क्वेश्चन पे आइए जल्दी से। विच रो गिव्स द यूनिट ऑफ एनर्जी एंड द यूनिट ऑफ इलेक्ट्रोमोटिव फोर्स।
एनर्जी जॉल,
शाबाश शाबाश शाबाश।
इलेक्ट्रोमोटिव फोर्स वी।
वी, वेरी गुड। तो इसमें मतलब ऑप्शन बी, वेल डन। नेक्स्ट, एक डायग्राम है। The diagram shows the electrical circuit containing 3 meters x, y and z are all connected correctly। ये सारे सही लगे हुए हैं। ओके, आपसे यही पूछेगा कि व्हाट आर द मीटर्स एक्स वाई जेड, क्या क्या है और क्या क्या मेजर करते हैं। तो चलो देख के बता दो। एक्स वाई और जी, इनमें से एमीटर कौन सा है और वोल्ट मीटर कौन सा है।
एक्स और जेड एमीटर है और वाई वोल्ट मीटर है।
वोल्ट मीटर है, वेरी गुड। तो एक्स और जेड एमीटर एंड वाई वोल्ट मीटर, तो ऑप्शन बी इज करेक्ट। वेरी गुड। अब आइए थोड़ा सा थ्योरी को टच करते हैं। ठीक है,
जी।
क्वेश्चन नंबर 7। ये 6 क्वेश्चन मैंने इसके एमसीक्यूज डाले थे। ये बहुत मतलब बेसिक लेवल से मैंने तुम्हें शुरू कराया और यहाँ पर भी हमारे काफी सारे इश्यूज हैं। अ डेफिब्रिलेटर, डेफिब्रिलेटर बेसिकली वो होता है जिससे हम ये इलेक्ट्रिक शॉक देते हैं। इज अ मशीन दैट सेंड्स एन इलेक्ट्रिक चार्ज थ्रू द हार्ट ऑफ द पेशेंट हुज हार्ट इज नॉट बीटिंग करेक्टली। ठीक है, तो उसको द डॉक्टर लर्न टू यूज द defibrillator by practicing on a medical dummy. Figure 7.1 shows two contacts of the defibrillator attached to
Sister,
the medical dummy. Assalamu alaikum.
I just reached home.
Oh, I think that you were far away from your home. That's why you could not reach
Yeah.
in time.
Yes.
Okay, okay. So today we are discussing some sort of, some tricky questions, not too much tricky, but some tricky questions related current electricity. So I have started from electrical quantities. So right after that, I will go to the second part of that. So here is the a question which is basically related to your charge and all that stuff. So that is a doctor, and doctor is going to give some electric shock to the medical dummy. Okay, and that medical dummy is basically used just for practice. So this was the story in the question. Now the question is, the contacts that touch the dummy are made from a material, from metal, and when the defibrillator is being used, one contact becomes strongly negatively charged and the other becomes strongly positively charged. That the handles of the contact are made from plastic, which is an electrical insulator. State how the structure of electrical insulator differs from structure of conductor. Yes, Hassan. How electrical insulator differs from electrical conductor.
Sir, electrical insulator, it resists the flow of electrons, so the electric current cannot pass through it. Whereas जो conductor होता है, it allows the
Mhm.
electrons to move through it. So
Okay.
the current
Yes. Yeah. Yeah.
passes through.
Uh,
Current
conductors
passes through
have
it. Yeah. Yeah. Do you want to add something?
conductors have free electrons which can move around, but in
Yes.
insulators all the charges are fixed.
Yes. So here the basic concept will be, Hassan. We have to, include this word. The conductors have free electrons, right? Conductors have, yeah, it has free electrons to move around. Okay. And what about the insulators? Insulators are, they do not have free electrons to pass through or to flow through. Free electrons. The game is free charges, free electrons to flow through. Okay, so you will score 1 mark over here. The next is, suggest why the handles are made up of electrical insulator. Yes, Hassan, आपसे शुरू करेंगे. Why the handles are made up of electrical insulators?
They have no free electrons, so the heat cannot pass through and burn your hand.
Heat. Good. इलेक्ट्रॉन्स का
ये
हीट
कौन
के
सा
साथ क्या
हैंडल्स है?
हैंडल्स है ना. तो
मैं तो
ये
यूटेंसिल वाले हैंडल की बात कर रहा हूँ.
मतलब मैं कुक किचन में नहीं बैठा हुआ. क्या करते हो प्रिंस विलियम हैरिस? हाँ.
Sir, it does not
These,
contain free electrons, so तो electricity pass नहीं होगी and
yes, and doctor will not be damaged. Yes, हमने डॉक्टर को तो नहीं बेहोश करना ना. If these handles would be made up of insulator, then instead of this dummy, the doctor sahab would be gone. Got it?
जी.
So we will say that because to prevent doctor from electric shock. Simple. To prevent, it is suggestion. Suggest why handles are made from the electrical insulator. So to prevent doctor from electric shock, as the insulator will not let the charges to flow through the doctor's body, as the insulator handles. देखो, there is a difference between thermal insulation and electrical insulation, right? All the things which are electrical insulators, it's not mandatory that they are thermal insulator as well. ठीक है?
जी.
Yeah.
Yes. So the shock, as the insulator handles are made up of, sorry, as the insulator handles do not allow the electrons are charges to pass to doctor body. Okay, is it
Yes.
clear to you,
Ji.
Hassan? Yeah. Are you agreed with this statement?
Uh, yes, yes.
Okay. The next is explain in terms of particles involved how one contact becomes negatively charged and the how the other contact becomes positively charged. This is very deep question. So just think, take a breath, and then answer my question. Hassan, I will start from you. Particles involved. So definitely there are some particles involved in the charging process. So I have to consider those particles involvement, that why one contact becomes negatively charged and the other becomes positively charged. Okay. Yes. Any idea?
Yeah. When the electrons build up in one side, they repel the
Yes.
electrons on other side. So
Okay.
as the
Yes.
as a negative charge builds, it goes away, a positive charge builds up in the opposite side
Okay.
of what's that called?
The
Device.
dummy.
Yeah.
Okay. So the negative charges are developed on one metal piece, and because the electrons have are wait. First, we will consider that positive charges are produced on one metal plate or one metal contact because they have been transferred, our electrons have been transferred from the metal through the wires to the other handle that becomes negatively charged. Sorry, that other contact that becomes negatively charged. Is it clear to you?
Okay. I thought it was about like a dummy and contacts.
Actually, we can consider, but we are not sure that whether this dummy is insulator or conductor. So, if it would be a conductor, there would be a short circuit in between these two, and there will be a spark generated,
Okay.
सर नहीं मुझे
right?
समझ नहीं आई ये
मैं
नेगेटिव किस तरह
समझाता हूँ.
हुआ पॉजिटिव
देखो, आपके पास this contact is losing the electrons, right? That's why it is getting positive charge.
यस
Or these electrons are traveling through the wires, right? And they reach to the next contact. That's why that becomes negatively charged.
सही
Got it? So
जी
we will write yes that the free electrons move from are transferred from one contact, are transferred from one contact and reached. Oh, wait. Here I have to write something. Contact, making it positive, because we have to make sure that we will not be penalized anywhere. Making it positive, okay, and reach to other contact, reach to the other contact, other contact through wires, through wires, making it negative, making it negative. ये बात clear है? Any confusion in this now?
Mm.
Yes, yeah. Is it clear to you as well? Hassan?
Yes.
Okay. The defibrillator passes a charge of 9.1 exponents -3 coulomb through a medical dummy in 6.5 exponent -4 seconds. Calculate the average current in the dummy. So, how to handle this question? What is given to us? Here we have charge, here we have time, and what we have to calculate? I. So, Hassan,
Current.
मुझे बताओ which formula will be used over here?
I is equal to Q divided by T.
Very good. Yeah, agreed. Yes.
Yeah. Yes. Yes.
Okay, so Q is your 9.1 exponent -3 divided by 6.5 exponent -4. So just solve it if you people have calculator. Please solve that.
So ये है 14.
Yeah.
14 ampere.
Yes.
Yes.
Very good. So is this clear to both of you? So you can solve these type of questions as your practice, but these are very short worksheets. I mean, I have just prepared these just for your topical revision. Now I'm going to have another one for you. That is that is your waves and sound and thermal and general physics. And here is, oh no, it is not going to be open with. Let's open it over here. I will try to solve that, solve on this sheet if it would be possible. Otherwise, maybe there would be some sort of issue. Okay, now are you people ready? Is it visible to you?
Yeah.
Yes.
Okay, here is, this is second assignment, or you can say the diagram, sorry, that quiz type, mm, assignment. I usually call these as an assignment, small assignment. A diagram shows a current carrying wire in a horizontal magnetic field. Which row shows the direction of the force experienced by the wire? Yes. First, Hassan would answer me first, and then Yahya will let me know about that. Hassan, पहली बारी आपकी. आज की पूरी क्लास में you will be opener, bowler, opener, wicket keeper, and opener. That's it. चलो. Yes, hurry up, hurry up.
Wait, who's answering?
Yes, you can, because ये हसान आपका टाइम पूरा हो गया है. आप
Okay.
आंसर करोगे?
नहीं.
नहीं करोगे? Use your brain actually, so you will be
ये वो
able to
थ्री
do that.
फिंगर रूल है ना इसमें.
Yes, exactly.
B.
Okay, yes, exactly. So, yeah, Hassan, can you please justify this? How is it B? शाबाश शाबाश शाबाश. इतना टाइम नहीं होता एक एमसीक्यू के लिए. Where you have to point your three fingers, how I have explained it to you. You have to point first finger in the direction of magnetic field. So just point your first finger and index finger in this direction. Then your second finger should be in this direction. I mean your middle finger. This is the direction of your middle finger. Okay, so where is your thumb pointing, Hassan? In this direction, na? So this is that. Be careful about these type of questions. Okay, is it clear now?
Yes.
Okay, next one. The diagram shows a DC motor which is coiled horizontally. DC motor is there and it is coiled horizontally. Why is a split ring commutator used? Yes, ye chalo first I will give a chance to Yahya because it is a difficult question. Yahya, it's your turn.
Just
I have changed the party. Hassan, meanwhile, you have to think about both of these questions, the upper one and the lower one. Question number one and two.
current. B.
Okay, so B says that to change that current direction in the coil as the coil passes through the vertical position. Okay, yes, it can be. So to change the direction of, it would be more appropriate if we use reverse the direction of current, but here because don't that is not an option. So change the direction of current as the coil passes over horizontally, horizontal position. No, because it is already in the horizontal position. So when these slip rings, sorry, these cuts would be in front of carbon brushes, so definitely the coil would have moved 90 degrees. That is why it would pass through vertical position. So change the current in the DC supply, no. To change the current in direction in the DC supply, no. So that is basically option B over here. Okay. ठीक है yeah.
जी.
Yes.
And Hassan, beta, is it clear?
Yes, sir.
So you have to recall this question. Now this is another good question from my resource pack, because that is in MS Word, so probably it would be shuffled if I will just make bit more problems with that. Which graph shows voltage output of an alternating makes one complete rotation या revolution? ये हसान बताएगा पहले.
Um,
Yes, yes, Hasan, hurry up.
B या C?
B
C.
या C? Okay, lock हो गया C.
जी.
Okay, yeah. Do you break that lock?
it's D.
Yes,
In C,
it's
it's not
D.
alternating in C.
Yes, we have to find out alternating. This is direct, this is direct, this is direct, because they are not changing the polarity. For alternating current, this must be, one must be above and one must be below. Is it clear, Hassan?
जी.
So this is the alternating का मतलब क्या होता है? Alter करता है ये. Voltage is sometimes the polarity is positive and for the next half of the time polarity is negative. So that is alternation. So please recall these type of questions. They are not hard ones, but they will make your life half hard if you will not work on these type of questions. Okay, this is the next question. Question number 4. Yes, a student moves a magnet into the coil, okay, of a wire as shown in the diagram. The coil of the wire is connected to a sensitive emitter. This is very important point. It is a sensitive emitter which change does not produce. Sometimes we are asked which change will produce, but here it is which change will not produce an increase in the reading. So we have to figure out that change which will not produce increase in the reading. Oh my god, that is wrong. It means what happens? Pink plus green equals to black. Okay, come on. So हसान से शुरू करते हैं. First one option is increasing the number of turns on the coil. Second option, increasing the resistance of emitter. Third, increasing the speed of the magnet. Fourth, increasing the strength of the magnetic field. So, according to your choice or according to your knowledge, which option is good option over here? Which will not, okay, which will make the reading greater? If you increase the number of turns, so Hassan, will the reading be increased?
Yes.
Okay, so it means it is not our choice. When you are going to increase the speed of the magnet, so will it increase?
Speed of the
Mean,
magnet.
yes, moving magnet faster. So will it increase the reading on the meter?
Yes.
Okay, and what about magnetic field strength? If you increase the magnetic field, I mean, we're using a stronger magnet. So, do you think that R would, sorry, emitter reading will increase?
शायद जी.
Yes. So the only option is R. So option B would be correct. So yeah. Do you agree or you have some uh,
Yes, agreed.
discussion on agreed?
Yeah, agreed. It's B.
Sure. Okay. Now it is Yahya's turn. First, I will give a chance to Yahya, and then Hassan will break the lock whether that question would be correctly described by Yahya or not. Yes, this is a good question. That's why I have given it to you. The diagram shows a coil connected to a battery and a switch. Two unmagnetized iron bars. Iron bars. This is important point over here that these bars are iron bars. Are actually here is very thick line, so I want to reduce its size. No, I cannot. Okay, leave it freely near they are hanging freely on the ends of the coil. What happens to the iron bars? What happens to the iron bar, not the coil, when the switch is closed? When the switch is closed, so what will happen to that? Hmm. Both.
B.
B, option B, you're going
Yeah,
to lock
both
it.
move towards the coil. 'Cause-
Both move towards the coil. Option B is locked. Yeah, is going to lock that. Hassan, what is your choice? आप क्या कहते हो? Yes, hurry up. It's an interesting question, yeah, isn't it? Yeah.
yeah,
If they would be they would be magnet instead of the iron bars, then the behavior would be different. But they're
yeah,
soft iron. Yes. So Hassan, soft iron की क्या property होती है? When it is brought closer to the magnet, either north or south, what is its response? जल्दी बताओ ना यार.
oh, yeah.
Hassan, are you there?
जी सर.
तो मुझे बता दो ना मेरा बच्चा, इतनी मिन्नतें गिराओगे तो हम सो जाएंगे फिर. बताओ. सॉफ्ट आयरन को सिंपली आयरन को, इफ यू ब्रिंग आयरन क्लोजर टू अ मैग्नेट regardless of the pole of the magnet, what is the behavior of the iron? कभी आपने लोहे का कील मैग्नेट के करीब रखा है?
So it comes closer to the iron magnet.
Yes, regardless of the bar, यानी regardless of the, क्या कहते हैं, pole on that.
It comes
ठीक है ना?
closer.
Yes. So because when north would be produced at this side and south would be produced at this side, iron has a property to induce opposite poles. So what will happen to the iron? It would produce south pole over here, and this would produce north pole. So south and north would attract each other. So both of these would come closer. Is it clear now?
Yes.
Yes. The next question. Okay. Oh, it is theory question. So let's try it. A circuit contains a battery, a variable resistor, and a solenoid. In figure 9.1 shows the magnetic field pattern produced by the current in the solenoid. So, did you see the diagram? Question number one.
Yes.
State how the magnetic field pattern indicates the region where the magnetic field is stronger. Yeah.
All right. The the more closer the uh what's that, lines of force.
Okay,
Yeah,
magnetic field lines.
closer are the magnetic field lines, stronger the field. So
Yes.
field is strongest in the core in
Good.
the inside the
Closer
solenoid.
the field lines, stronger the field. Stronger the field. Hassan, beta, is it clear now?
जी.
So, field is stronger inside the core. Field is stronger inside the core. Inside the core. Got it? Because magnetic fields are very closer to that. Okay, ji. State what happens to the magnetic field when the current in the circuit is reversed. Wow, what a question. हसान बताएगा पहले. What happens when we reverse the current? Magnetic field का क्या behavior होता है? Is it increases, decreases, reverses, whatever? Hassan.
Decreases.
Okay. Yeah.
Still, when the current is the second part, right?
Yeah. Part two. Yes. I just
Yeah.
noticed that Ariba is also over there. Ariba, next I will ask the questions from you. Yes.
So
All right, sir.
can you
Okay.
share the screen again?
Oh, is it lost?
Yes.
Oh my
Yes,
God.
sir.
Yes. अरीबा तुमसे पूछना कि जब जस्ट मैंने सोचा तो स्क्रीन गायब, इसलिए I changed my plan. Don't worry.
Huh? No, the question.
Yes.
The
Here is
circuit
that.
is reversed. The poles of the field
Mhm.
swap.
Yeah. Here is that. You can see this one. So if I
Yeah.
reverse the poles, what will happen? Initially, north is yes. Initially, this is north because magnetic field is generating from here, and it is south because they are coming into. So when I reverse the poles, I make this bar positive, and the other one would be negative. then this would become north and this would become south. So please remember this thing, uh, all of you, that when you reverse the poles of the battery, the magnetic field is reversed, right? The magnetic
Yes.
field is reversed. ठीक है हसान, डिक्रीज नहीं होती मेरा बेटा. The magnetic field is reversed. Magnetic field is reversed. It is just state. No need to explain anymore. But 1 mark is enough for us. Okay, is it clear?
Yes.
This is another horrible question. So be ready, all of you. A second solenoid is placed next to the first solenoid. Okay, this is mean just like a transformer action. Just telling you one thing right from here, that it is behaving just like a transformer. So when I say that a second coil is placed near the first coil as shown in the figure, okay, emitter is over here. So that is yeah, did you see that diagram? Second solenoid,
Yeah,
then
but
this is first
this is
solenoid.
DC.
Oh my god, why did you break the suspense of the story, man? It
Sorry.
was the horrible horror show. That's why I announced
Sorry, sir.
it before. Okay, no problem. It is a pre-release, so the variable resistor is just so that adjusted so that the resistance is changed quickly. Here is the game in this question, actually. You know, this is just the scene in the horror movie when the doors are just closed automatically and sound is being produced. So, and it's changed quickly. State and explain what is seen to happen in the circuit of the second solenoid. Yes. Yeah, yeah. The game is changed, huh?
Yeah. So,
Is the game changed?
yeah. Now there's changing magnetic field. So
There's a twist in the story. So, Ariba, Bismillah Rahman Rahim. Go ahead.
Sir, can I just think about this for 2 minutes?
In 2 minutes, we will be completing these 3 marks question. Okay, okay. You have to think about that. Meanwhile, Hassan, did you know about that? Hassan, I think that when I speak to you, my electromagnetic radiations becomes more slow. They cannot reach to you. The speed of the electromagnetic
mm,
rays becomes very, very less. For other people, they travel at the speed of light, 3.0 into 10 raised power 8.
physics is being broken. Very good.
Yes. Hassan, hurry up, hurry up.
So the solenoid is being placed next to another solenoid, am I right? With the
Yes.
ammeter.
Yeah, exactly. It has an
Um,
emitter just to indicate that.
is the
There is
ammeter
something.
gonna deflect?
Yes, of course. But
Right,
why?
because of the magnetic field? It'll like it'll affect the coil.
Okay. Yes, yes. Just
So
complete the
that means
puzzle.
that
You're
means
just
there's gonna be
giving me a puzzle.
electromagnetic something something in uh is it electromagnetic induction, I think. I'm
Yes.
not
Yeah,
really
yeah. Isn't it like a puzzle? She's going to tell all these points.
Huh?
Just complete
Sure.
it if you can. Yes. So yeah, yeah, you have to
Uh,
complete the puzzle. Then I will try.
uh, all right.
She has
So
given you
I explain
3 points.
why it changed. Wait, I have to explain why
Um,
it changed.
no, no, no. It is a variable is adjusted. it has its
All right.
resistance is
So,
changed quickly. So what is happening
so when
to
resistance.
the circuit of second solenoid? So
Okay.
she has told you
Okay. I
fluctuation
get
will
it.
be there. Yes.
Yeah, yeah.
Okay. So
So,
solve the puzzle.
okay. State explain what is seen to happen in the second solenoid. Fluctuation happens. Yeah, I mean,
Yeah. This was one part of the puzzle.
the ammeter shows current for a
Yeah, that is same thing as
short period of
fluctuation.
time. Yeah,
Okay.
but do I have to explain why it happens or just
Yes, you have to score 3 marks. She told 3 points,
okay then?
exactly 3 points. But we have to connect them because she had a random idea. But I want that you
But
have to connect all
I
those
couldn't
points.
hear.
Okay, yes, Ariba.
I couldn't hear it, so
I'm quite
I will
sure
make
it's like the ammeter needle is gonna have fluctuations and it's gonna like deflect. So
Mhm.
there's gonna be a magnetic field that will affect the coil, causing
Okay.
electromagnetic induction. It's something like this, I think. I don't know. I'm
Yes,
terrible at
these were
okay.
the
All
clues.
right.
All right,
When
now
the
do you get it?
when the when the current in first solenoid change, the
Mm-hmm.
field changes, which
Good.
induces current in the second solenoid, and
Well,
which creates current in the second solenoid, and it's seen as a deflection in ammeter. This is
okay.
all I can do.
Yes. Good. Good. You solved it. To maximum level. I want to add one more uh, slot over here that she stated electromagnetic induction. That slot was missing. So how to adjust that? हसान इतनी देर
So
में तुमने भी सोचना मेरा बेटा मैं तुमसे पूछूंगा ऐसे मैं चुप नहीं रहने दूंगा समझ आई
let Hassan solve.
Hassan now electromagnetic radiations have been stopped to reach him I believe that Hassan सो रहे हो जाग रहे हो
जाग रहा हूँ.
तो बताइए क्या होगा there will be very good yeah both of you tried your best there will be a change in current in first solenoid due to change in resistance due to yes due to change in resistance and after that what will happen this would cause a change in this will this causes a change in magnetic field strength or magnetic flux density this is the appropriate word magnetic flux density in first coil till this point is everything clear to all of you
Yes.
this these magnetic field lines are cut by the secondary coil this is the point where I was saying that you have missed one slot of the puzzle the are this magnetic field this magnetic field oh sorry, these magnetic field lines, these magnetic field lines are the magnetic field lines. That's, I'm not very good in English, that's why I don't claim that this sentence would be some sort of grammatically or something, some other category, some other ways it would be correct, but I can give you physics behind it. These magnetic fields are cut by second coil, and induction takes place, or magnetic, wait, electromagnetic induction takes place. Electromagnetic induction takes place. Induction takes place, right? Rate of change of rate of change of magnetic flux, the secondary coil, magnetic flux in, you can write any 2 3 points for this because it is of 3 marks. So three points are mandatory. Magnetic flux in second coil causes an induced current in it. Induced current in the emitter. That's it. Is it clear to all of you? Now it would help you a lot to make a clear concept of electromagnetic induction. Is it? Unfortunately, I was not having a suitable space for that, so I could not write it properly. But it is very, you know, tiny writing. So just consider it. State and explain. Oh, the variable resistor is now adjusted much more slowly than in one. State and explain the difference in what is seen to happen in the circuit of the second solenoid. अब हसान ये वाला क्वेश्चन तुमने जल्दी बताना और 1 मिनट के अंदर अंदर बताना, मतलब 1 मिनट से अंदर अंदर मैं क्वेश्चन लिख लूं. जल्दी बताओ, शाबाश. हरी अप. हसान हरी अप. हेलो सर हसान, आर यू देयर? Okay, Ariba, what's your choice?
Sir, can I think about it? My head's spinning.
Okay, no problem. When it would be stopped spinning, then let me know.
So my turn.
Yes, it's your turn.
All right, there will be a deflection, but the amount of current will be less, but deflection will
Yes.
stay for a longer time period.
Oh, good. Deflection is still there, but with smaller magnitude and long time. Is it? You want to say this thing?
Yes.
Very good. So, Ariba, are you agreed?
Sir, could you explain this to me?
Yes. Magnitude and for long time. Actually, it is said that now we are moving that, or we are adjusting this coil or this current slowly. So when it would be moved slowly, the EMF at the output is directly proportional to rate of change of flux. How faster you are moving the magnet or how faster you are changing the current, that EMF is induced accordingly. So here we go, that if you are going to move this more slowly, then what will happen? The EMF would be reduced, so the magnitude of output would be decreased. But if it is moved slowly, it means the magnitude, the deflection will take time to be changing. For example, this was 0, this was 10. So initially the deflection or the meter was changing from 0 to 10 in 1 second. Now it would not go to 0 to 10, it would get to 8, let's say, but it would take time, more time, because you are moving it slowly. Got it?
Yes, sir.
Yes.
Okay, good. Here we go with what happened to you? Oh, this is the problem. Sometimes, Hassan does not speak, but his heart bleeds at that time. And
Yeah.
that happens with me over here.
Yeah.
Yes. This is
I
next
think his
question.
heart beat a bit too much because he just disconnected as well.
Yes, exactly. So 10.1 shows a coil of a wire rotating steadily in the magnetic field between the poles of the permanent magnet. The current generated in the coil is to pass through the resistor R. Okay, that is the coil to be sorry, current is to be passed through that coil through that resistor R. So we are here. Cool down. Okay. Wait. If it will give me one chance, I will save it as a PDF and then I will work on it. Because it's too difficult for MS Word to uh, respond on the writing stuff. PDF is very perfect thing. Yeah. Where is my desktop? Yes, here is that. So just me save it as PDF so that it would not be wasted what we have done. Okay. Yes, it is saved. Alhamdulillah. Don't save, please. So here we go. I'm going to open that file again in that PDF format, and we will work on it. Yes, here is that. Yes, come on, boys. 10.1 shows a coil of the wire rotating steadily, right? It has rotation, the magnetic field between the poles of the permanent magnet. The current is generated in the coil to pass through the resistor R. So the permanent magnet, the operators in figure 10.1 is a part of an AC generator. This is the key concept for you over here. That is the part of an AC generator. What is connected between the ends A and B of the coil and connection C and D. Yes. So I will give a chance to Hassan first.
Sir, I told you Hassan's heart bleeded a bit too much. He
Ah,
is disconnected.
oh, sorry. Sorry.
Sir.
It was inertial condition. I don't know. Due to inertia, I just yes, yeah.
Also, can you scroll up a bit? I want to read the question again.
Yes. Ariba, when is your class starting? Next class?
Yeah, slip ring.
In 15 minutes.
Okay. We will complete this question, inshallah. Okay. Yes. Yahya told me that there would be slip rings, right? So
Yeah, slip
what
ring
has
indicators and brushes. No
brushes?
brush.
So Ariba, are you agreed with
No,
I
no
thought
this
it
brush.
was just
electrical
slip
engineer?
rings. I thought it was slip rings.
Yeah, just slipping, no brush, no brush. Sorry.
Okay, why, man? Why are you just reverting back your idea? The apparatus is a part of AC generator. So first we have to connect two slip rings over here. Okay, and these two slip rings are actually not directly connected. They are connected with some sort of rotating mechanism. Okay, so here we go. These are two carbon brushes. Sorry, these are two slip rings, and then we would have two carbon brushes attached with those, which would make the rotation possible. Otherwise, that would twist the load.
All right.
Yes,
Uh,
is it
there
clear?
was, yeah, the question's answer was 1 point. I thought I was supposed to give one.
Yes, both correct. 1 mark. This is that
All
question.
right. All right.
Okay.
Sir, physics is so mentally draining. When I'm gonna go for the exam, I'm gonna write the magic of friendship is holding everything together. I can't do this anymore.
No problem, no problem. It would compel you to do to think about that. It has a magic.
I really hope
Okay,
so.
so you will not get escape of this magic. It's I'm really, I mean, honestly telling you, it just it does not make any choice to you when you get uh, a good understanding of physics, na. So it attracts you so brutally towards itself. You cannot get escape of it. Everywhere in the universe you will be trapped. Oh, here this law of physics or this physics is being applied, and so that makes life more horrible. Okay, on figure 1.1, 10.2, sketch the graph to show
All
the
those
variation
motivating
with time.
words, and then so you just give like a motivational speech and say it makes life more horrible.
Actually horrible means, um I think horrible is something different when the
Sir,
things
I'm not
are
masochistic,
not.
please.
Huh?
I'm not masochistic. I do not enjoy horribleness.
No, 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 no. Horrible means, let me explain my statement. When the things are not known to you, awareness is blessing. It is once saying. Do you know that? Unaware, sorry, ignorance is blessing, or unawareness is
Yeah.
blessing. Is it? So when you are not aware of the consequences and results and laws and rules, you enjoy the life. But when you know that if I will jump from here, I will be falling with this much speed, and when I will hit the ground with this speed, what will happen to me? Or some other things. For example, if I have some sort of electricity and I know that 220 volts would flow through the body of 100 ohm resistance, sorry, 1000 ohm resistance, then how much current would flow through my body, and I will be just fried. So this makes your life, more horrible. You become reserved, and to
Um,
somehow, mm,
second one was more of experience for me, but anyway.
yes. Now
I
come
mean,
back to the question, because hmm?
yeah, yes, yes. That's good question.
Yes, yes, you can explain your statement, no problem. I have time.
Uh, it was just 20 volt, but that was enough for me to learn.
You had not experienced 200 volts, man,
No,
because
no, 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 no. That's too much. I will get paralyzed at that point.
it's too much, really. Because I believe that, I mean, 99% of the people who have born and grown up, they have experienced this electricity. 99%. I mean, little or more, but they have experienced it. I will tell you how I experienced that, but later on when I will complete that. So on figure 10.2, sketch the graph to show the variation with time of the current through R. So we have to uh, draw the direction of current on figure 10.2. On figure 10.2, show the time corresponding to one complete rotation of the coil. So these are two identical points. I mean, that is 10.2, that is 10.2. So I have to show that when current would be maximum and when current would be minimum. At time t is equals to 0, that coil is placed in this way, the horizontal position, right? So as I told you, that when the coil is at horizontal position, the current in the coil is maximum. So we will start trying in this way. This is the trap in this question. Most of the student basically draw that in this way. Okay, they complete the graph, it's fine, sinusoidal graph. But I will mention this thing for you right over here. I mention this frequently because it is a question which is more problematic from AC generator, that where the current would be maximum and where the current would be minimum. So at this position of the coil, the current would be maximum in the coil. When the coil would be vertical, the current would be 0. Again, when the coil would be horizontal, current would become maximum. Again, when the coil will become vertical, current would be 0, and so on. It would be basically, this is the position of the coil. Okay, so if I say that is, okay, this is your time t is equals to 0. This is your t by 4. This is your t by 2. I mean, after half time. Then this is the full time after one time period. So here you have to mark t. And if you want to complete that, here you have to mark 2t. Is it? Is it clear to you?
Yes.
Okay. So be careful about the direction of position. State two ways in which the graph would be different if the coil spins at faster rate. Oh, faster rate. Wow, wow, wow. So one is the magnitude of voltages are the magnitude of graph would be increased. How? That the magnitude of current would be increased simply. Magnitude of current increases. Okay. So when magnitude of current increases, what does it mean? Graph would be high. Peaks will be high. Peaks will
Or
be high,
amplitude?
higher peaks. Yeah, amplitude, exactly. I was not able to drag that word to my brain. So amplitude increases. Okay, so this would be
Alright.
the correct description of this graph. And what is the next?
Higher
It would have
frequency.
more cycles. Yes, so it would have higher frequency. Higher frequency. Higher frequency can be further explained that peaks would become closer. Peaks will be closer. Got it? So this was basically today's very interesting task. I really enjoyed this class. You people have contributed very well. Okay, you have even participated. Sorry, again, wrong use of word. So I'm going to send you this worksheet for you from electromagnetism. Just one question is left, I think so. So I believe that you people, yeah, two questions are left. So I hope that you will be able to handle this. Okay.
Yes. Alright.
Okay,
We
sir.
So
can.
meanwhile, yes, you people are supposed to continue your work from all papers. First, we had decided to complete the MCQs. I believe that you would reach to 2018 or something like that at this time. So where are you, Yaya?
I think so. I'm still in 2020s actually.
Okay, so just complete it as quick as possible. And Ariba, you are just to work in regular pace, but not faster. Okay, regular and fast have difference. So you have to be slow and steady. So
Okay,
definitely you
sir.
have to win the race. Okay, see you then. Allah Hafiz.
All right, sir. See you. Have a good day.
Allah Hafiz. Thank you.
Allah
पुत्र
Hafiz.
अभी इधर रात हो रही है, सोना है मैंने.
Ah, yeah. Have a good rest, sir.
ठीक. Thank
What?
you, thank you.
Allah
She
Hafiz.
was saying that have a good day. So I told her that okay, here is night time. I have to sleep now.
Oh,
Yes,
chill.
that was the time domain difference, time zone
I
difference. So are you back in Pakistan?
no, I'm still